Hello and welcome to Earthquake Tip number 20. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to comprehend language to our professionals who are in the field designing and constructing structures, especially our architects and engineers. But before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. This earthquake tip number 20 will explain you how do beam column joints in RCC buildings resist earthquakes. Remember, we have already discussed beam and column and their behavior and detailing for earthquake resistant design. And now let's discuss beam column joint and why these joints are special for earthquake resistance. Let's see this figure. In RCC buildings, portion of column that are common to beam at their intersection are called beam column joints. Since their constituent materials, that is concrete and steel, have limited strengths, the joints have limited force carrying capacity. When forces larger than these are applied during earthquakes, these joints get severely damaged. Repairing of these joints at a later stage may be a difficult proposition. So these damages should be avoided, and therefore beam column joints must be designed to resist earthquake effects. Now let's understand the earthquake behavior of joint. As you can see in this figure, the beam at adjoining a joint are subjected to movements in the same directions, that is either clockwise or anti-clockwise. Under these movements, the top bar in the beam column joint are pulled in one direction and bottom ones in opposite directions, as you can see in this figure 2A. These forces are balanced by bond stresses which are developed between concrete and steel in the joint region. If the column is not wide enough, or if the strength of column in the joint is low, there is insufficient grip of concrete on the steel bars. In such circumstances, the bar slips inside the joint region and beam loses their capacity to carry load. As you can see in this figure, we under the action of pull and push forces at top and bottom ends, joints undergo geometric distortion. That means one of the diagonal length elongates and one other length compresses. So if the column cross-section size is insufficient, the concrete in the joint will develop diagonal cracks. Now let's understand how to reinforce beam column joints. Problems of diagonal cracking and crushing of concrete in the joint region can be controlled by two means as shown here in this figure. First of all, provide large column sizes. Secondly, provide closed spaced steel ties around the column bars in joint region. These ties, as told you in earlier tips as well, are the most important ones as they hold together the concrete in the joint and also resist shear forces, thereby reducing the cracking and crushing of the concrete. Now, providing these closed loop ties in the beam column joints require some extra effort. The ductile detailing code recommends continuing the transverse loops around the column bars through the joint region. How this is to be done is explained through this figure. As you can see in this figure 4A, B, C, there are three stages. This can be achieved by preparing the cage of reinforcement, that is, both longitudinal bars and closed loop ties of all the beams at the floor level to be prepared on top of the beam formwork of that level and then lowered in the cage. However, this may not be possible, particularly when the beams are long and entire reinforcement cage becomes heavy. The continuity of reinforcement at beam column joints and their anchoring is also very important. Now let's discuss that through this figure. The gripping of beam reinforcement bars in the joint region is improved firstly by having column sizes reasonably large. Remember, in earlier tip, it was told that column in seismic zone 3, 4, 5 to be at least 300 mm wide in each direction of cross section when they support beams that are longer than 5 meters or columns are taller than 4 meters. The ACI, American Concrete Institute, even recommends a column width of at least 20 times the diameter of largest longitudinal bar used in adjoining beam. Now, let's see how do we anchor these beam bars through this figure. In exterior joints where beam terminates at the column, the longitudinal beam bars need to be anchored into the column to ensure proper gripping of bars in joints. The length of anchorage is 50 times its diameter and it is measured from the face of the column to the end of the bars anchored in the column as shown here in this figure 5a. If the column of small widths and when beam diameters are of larger diameter, a portion of top bar is embedded into the column that is cast up to the soffit of the beam and part of it overhangs as you can see here. It is difficult to hold such an overhanging beam top bar in position while casting the column up to the soffit of beam. So what should we do? Let's see in this figure 5b. If the column width is large, then the beam bar may not extend below the soffit of the beam. Therefore, it is preferable to have columns with sufficient width as shown in this figure 5b than the narrow columns. Now let's see this figure 6, which shows you the interior beam column joints. In interior joints, the beam bars, both top and bottom, need to go through the joint without any cut in the joint area. Also, these bars must be placed within column bars with no bands as shown in this figure 6a and 6b. If the beam bars are bent, then it's a poor practice, and if they are not bent, then it's a good practice. Figure 6c shows you a typical shear failure of RCC beam column joint during 1985 Mexico City earthquake, where beam bars are passed outside the column cross section and therefore failed. This is all about earthquake tip number 20. You can download this earthquake tip from www.bmtpc.org. The next earthquake tip number 21 will be on why are open ground story buildings vulnerable in earthquakes. Thank you.